All right, welcome to example 3. This time we are going to be trying to prove that angle A and angle D are congruent in these two triangles. So we can see those are the angles at the tops of our triangles here. And what do we know? So we know that angles B and E are right angles. Those are marked here with little boxes. We know that AC and DC are congruent. And we know that C is the midpoint of BE. So we've seen in the previous examples that by the definition of the midpoint means that BC and CE are going to be congruent, so that's great. And just as before, we're going to be trying to prove the two triangles are congruent in order to prove that the corresponding parts of the congruent triangles are congruent. CP, CT, C is where we're trying to get to. But how do we get there? We've got two sides, so we can't use side, side, side because we don't really have a way to prove that the third side is congruent. We do have a couple of angles, but they're not the included angles, which is going to be a problem for the postulates that we know. So we're kind of stuck. But fortunately, what do we know about these triangles? These are right triangles. Why are they right triangles? Well, they have a right angle. If a triangle has one right angle, then it is a right triangle. And right triangles introduce a whole bunch of other theorems that we can use to prove congruence of triangles. So there's HL, there's HA, there's LL, so that's like leg, leg, hypotenuse, leg. These are going to be useful here. So what do we know about these right triangles? So we've got the AC and DC, and those are the sides opposite the right angle. So those are, each one of these is the hypotenuse of these triangles. And then we also know BC and CE, and those are legs, are congruent. So we've got a hypotenuse and a leg, and that sounds an awful lot like the HL theorem. So that's what we're going to try to get to. If we can say that in a proof, then we can say the triangles are congruent. If we can say the triangles are congruent, then we can say that the angles, the corresponding angles, are congruent, and that's what we want to do. So let's see what that looks like in a proof. We've got our statement of reason columns. We've got a bunch of boxes. And let's start off with the first thing that's given to us, which is that angle B and E are right angles. That is given. That's our reason. That's our justification. And then we want to say that triangle ABC and DEC are right triangles. And it's important to say that at some point in this proof, because if you don't say that, we're not able to use the HL theorem. You can only use the HL theorem with a right triangle. So we need to say that we're working with right triangles. And so the reason we can say that is the definition of a right triangle. We know the definition of the right triangle is a triangle that contains one right angle. We've just said that these triangles have right angles. Therefore, we can say the definition of the right triangle shows us that these two triangles are right triangles. Okay, that's established. Now all of the right triangle theorems are on the table for us to use. Next, we're going to say that C is the midpoint of BE. That is given. And then we can say BC is congruent to CE. That is the definition of a midpoint. Then we're going to say AC is congruent to DC. That is given to us in the problem. And so now we've got our, well, they're out of order, but we've got our leg and our hypotenuse. And again, it doesn't really matter the order, so that's fine. We just have to have both of these things as statements before we can say triangle ABC is congruent to triangle DEC, and that is because of the HL theorem. So if that's all we want to do, we were done. But we've got one more thing we've got to say. We've got to say angle A and D are congruent. Looks like I'm out of boxes, but that's okay. That'll happen sometimes. All you need to do is add another box. So that's what we did here. So we've got angle A is congruent to angle D because of CP, CTC. Congruent parts of congruent triangles are corresponding parts. A lot of C's. Corresponding parts of congruent triangles are congruent. And that was what we were trying to do.